To finish the examples from yesterday first. Just as a recap, and if you haven't, if you had looked at some of this practice, I know I pointed out based on what we went through yesterday, there were some practice problems you could have done. If you looked at that and had questions, either end of class period today or even tomorrow when we go through questions, if you still have questions from this practice set, I will gladly go through those as well. But properties of exponents we talked about yesterday, we will use those a little today as well. And then with polynomials, we had just started out determining if an expression is a polynomial. And then we started talking about the degree as well. And what we did not have time to get to yesterday with the shorter class period was actually adding and subtracting polynomials and then multiplying. And then today we're starting one of the processes you can use to divide. And then I also want to talk more about the degree just to get you thinking of the degree of a polynomial as well. So some of you, like I said, I know when I walked around yesterday, you had already kind of looked ahead at these to try them. So just make sure if you did that, that you have them right on your note sheet when we go through. But for example 3, notice in between the parentheses in A, there's a subtraction sign. In between the parentheses in B, there's an addition sign. So this is very similar to when you added or subtracted complex numbers in the last chapter, that the parentheses are just separating one polynomial from the next. So it's this polynomial minus this one, this polynomial plus this one. All you do is combine like terms. You add or subtract like terms. Now, what I would recommend when you're subtracting is that you actually distribute the subtraction sign through, rewrite it, and then combine so that you're not forgetting to subtract all of your terms. So when I distribute it through, I can rewrite this without parentheses. So I still have 2a cubed plus 5a minus 7. But then distributing the subtraction sign, I get minus a cubed plus 3a minus 2. And then I can just combine like terms. So we've worked with like terms already this year. Because all of our variables in this expression are a's, just make sure you're only grouping the a's that have the same exponent. And when you do combine like terms, you don't change the exponent. You only combine the coefficients. So if I have 2a cubed minus a cubed, that is just positive a cubed. Or if you had 1a cubed, that's okay. But it doesn't change to a to the 6th or anything like that. And then I have positive 5a plus 3a. So that would be plus 8a. And then negative 7 minus 2 is minus 9. So a cubed plus 8a minus 9. So if you had that already from yesterday, just double check that you have it correct. So that's how you subtract. You're just subtracting like terms. I would recommend distributing the minus sign through. You don't have to do that as long as you just make sure you're subtracting everything. But then it doesn't ask this in the problem, but I just want to review since we're going to talk about the degree of a polynomial a lot throughout this chapter. I want to identify the degree. So the degree of a polynomial, if you only have one variable, so we only have the variable a, the degree of a polynomial is the highest power that you see on the variable. So the highest power of a is 3, meaning this is a polynomial of degree 3, or a third degree polynomial is how we could identify it. Okay, so even though it's not asking, I just kind of want to think about that today, what the degree is, to get you used to that idea for when we talk about it more later. And then for b, just quickly, when you're adding, you could rewrite this if you wanted to without parentheses, but here you're just adding like terms. So if I have 4x squared plus negative 2x squared, that would be 2x squared. Negative 9x plus negative 5x is minus 14x. And positive 3 plus negative 6 is a minus 3. So make sure you recognize if there's a symbol in between so that you are not accidentally multiplying when you shouldn't be, because then your answer is incorrect. For b then, what would the degree of that polynomial be? 2. So I also want to point out, connect to what we just did in Chapter 4. Everything with quadratics in Chapter 4, quadratics are polynomials. So this is a quadratic expression, 2x squared minus 14x minus 3. That's in the form ax squared plus bx plus c. Quadratic is a polynomial of degree 2. Highest exponent is 2. So just think we still could be graphing parabolas in this chapter because they're polynomials. We still are going to be factoring in this chapter because we have quadratics, and we'll learn how to factor when you have a higher degree as well. So all of those concepts we learned, we're going to build on those through this chapter. So that's adding and subtracting, and then the next two are multiplying. So you have already multiplied polynomial expressions. We multiplied in Chapter 4. So in example 4, if we're multiplying negative y by 4y squared plus 2y minus 3, this is just distributing the negative y to the 4y squared plus 2y minus 3. But then you need to remember your properties of exponents when you multiply. So if I multiply negative y by 4y squared, I'll have negative 4y to what power? 3. So when you multiply, then you do add the exponents. Y to the first plus y, or times y to the second is y to the third. So then negative y times 2y would be minus 2y squared. And negative y times a negative 3 is plus 3y. So this would be the simplified form. And what would the degree be? 3. Highest exponent. And then for example 5, this is very similar to the process of FOIL, but it isn't exactly FOIL, because FOIL is when you have a binomial times a binomial, so 2 terms times 2 terms. Here we have a trinomial, 3 terms multiplied by a binomial. But the process that you use with FOIL, it's very similar. So a way to think through this is I'm going to take every term in the first polynomial and distribute it to the a plus 2. So I'm going to start with the a squared and multiply a squared by a and a squared by 2. So a squared times a would be a cubed. A squared times 2 is plus 2a squared. Then I do the same thing with the 3a. 3a times a, 3a times 2. So 3a times a would be plus 3a squared. 3a times 2 is plus 6a. And then I do the same thing with the minus 4. So negative 4 times a, negative 4 times 2. Negative 4 times a is minus 4a. Negative 4 times 2 is minus 8. So it's just making sure everything in that first polynomial gets distributed to the second one. And then you combine any like terms that you have. So I just have a cubed, positive 2a squared plus 3a squared is plus 5a squared. 6a minus 4a is plus 2a, and then I still have minus 8. And then what would the degree be? 3. All right, so are there any questions on adding, subtracting, multiplying polynomials at this point? Okay, so if you had started to look at this practice or haven't looked at it yet, just know that it's there. This would be practice from this lesson. Any questions on that, like I said, at the end of class or even beginning of tomorrow, I will still answer questions there. All answers are in the back except for 40. So I will show that answer at the beginning of class tomorrow, or if you already looked at 40 and want to check today, just let me know. I can show you that. So just know that that's there. I know this is a little different because we're splitting between 2 lessons, wrapping up before we move on. But then 5.2, so this actually ties in nicely because we just looked at how to add, subtract, and multiply. So 5.2 is just on dividing polynomials. And we are focusing on polynomial long division. However, example 1 is not long division. Example 1 is just dividing by a monomial, dividing by one term. And that's actually using the properties we learned yesterday. So before I get too much into describing the long division, let's look at the examples under example 1 first. So when these say to simplify, I just want you to notice, even if you look at A, we're taking a polynomial and just dividing by one term. So all of these are divide, you could write divide a polynomial by a monomial. I just don't want you to get, when you're kind of looking back at the long division, I don't want you to get example 1 confused with the long division, because this is not long division yet. So when you divide a polynomial by a monomial, and I'm going to write this out perhaps in a way that you won't have to every single time, but just so you understand what you're trying to do, what happens is you take every term in your polynomial and divide it by the monomial. So I'm taking 20 c to the 4th d squared f and dividing it by 4 c d f. Then I'm going to carry down the minus, and then I do 16 c d f squared divided by 4 c d f plus 4 c d f divided by 4 c d f. It's very similar to, I'm going to be relating division to factoring because factoring is a form of division. So this process is similar, like if I said, here's a polynomial and the greatest common factor is 4CDF, you're working through it that same way. You're dividing everything by 4CDF. So when we divide, now we're using those properties we learned yesterday, or one of the properties at least. For the first term, I divide the 20 and the 4, and that's 5. And then when you divide variables with the same base, what do you do with your exponents? Subtract. So I would have c to the 3rd power, d to the 1st, or just d. If you write the 1, that's okay. The f's would cancel out. And then carry down the minus. For the next term, 16 divided by 4 is 4. The c's cancel, the d's cancel, f squared divided by f is just f, or if you had f to the 1st, that's fine. Plus 4cdf divided by itself would be 1, yes. Everything cancels, just make sure you don't say that's 0, it is 1. If everything cancels out, it's 1. So this would be your quotient. So like I said, this is very similar to when you divided or you factored out a GCF. It's, I know it's worded differently, maybe it's thought of differently, but it's the same process. So then B, because B is written differently, B is written as this polynomial multiplied by 3xy to the negative 1st. So if you think back to yesterday when we talked about how to make an exponent positive, if we think of this all being over 1, to make this quantity a positive exponent, we would move it to the bottom. So a power, or multiplying by something to the negative 1st power, is division. So this would be the same if I wrote it as 18x squared y plus 27x cubed y squared z divided by 3xy. And it would be the quantity 3xy to the 1st, which is just 3xy. So when you see that notation, if you're multiplying by something to the negative first power, just make sure that you understand that's the same as division. Okay, and then you would simplify this the same way we just did part A. So what I would like you to do is continue simplifying B and then also simplify example C. And then we'll double check that we're on the same page with these before we move on. So continue, finish part B, and then also answer C. Walk around. If you have questions, let me know. I'm just going to check that you have time to answer them. All right, some of you I know might be finishing up, so if you want to finish the problem before you check, but once you are finished with both, just double check your answers. And like I said, you've kind of done this process already. So you could, with these types of problems, you could check your answer if you multiply this by what you divided by. You should get your original polynomial. So you could check it that way. If you're interested in checking, are there questions before we move on? Okay. So then when you are dividing a polynomial by a polynomial that has more than one term, so you're not dividing by a monomial. So for example, like if you look at example 2A, you're dividing by x minus 3. You're not just dividing by one term. Then there's two processes that you can use to do this, and actually a process that isn't either of those two, but it's something that you've done before. I'm going to relate it to that as well when we go through A. But one process you can use is polynomial long division. Now we're gonna kind of take a trip back to second hour determined. It was maybe 4th or 5th grade where you learned how to do long division. I'm not sure exactly. I don't teach elementary school, but I'm going to write, this is not from anywhere on your sheet, but if you want to include it, I'm going to go through an example with numbers of how to divide numbers using long division. Review that process. So let's say I want you to divide 984 by 8. We're going to use long division to do that. So review this process, because even though we have polynomials, that part is different. The long division process is the same. So if you remember doing long division with numbers, that'll help you with polynomials. So you might remember with long division, you would set it up this way. So 984 is inside of that division symbol, 8's on the outside. And then I'm going to review some terminology with you too. Here, the number that is being divided, so the 984 in this case, there's three kind of terms with division in a division problem. The number being divided is called the dividend. So you might remember this. I'm reviewing this because if they talk about this in this chapter, you see this terminology, you hear me say it. It applies to polynomials as well. in the division process. So the number being divided or the quantity being divided is the dividend. The number or quantity you're dividing by is the divisor. And then the last one is the answer that you get. And what's the answer to a division problem called? The quotient, yes. So that'll be the third one, but we don't have the quotient yet. So the dividend and the divisor, though, you might remember those when you learned the long division process. So when you long divide, does anybody remember where to start? Like, how would you start this if you're doing a long division? Grace? Yep. How many 8s or how many times can 8 go into 9? The first digit, how many? 1 time. The 1 you wrote above. And then what did you do? Yep, multiplied the 1 by the 8 and wrote it underneath, and that's 8. And then I heard somebody say you then subtracted. So 9 minus 8 is 1. Yep, you then bring the next digit of 8 down below. And then you repeat the process. So now how many times does 8 go into 18? 2 times. 2 times 8 is 16. Subtract. 18 minus 16 is 2. Bring down the last digit of 4. 8 goes into 24 how many times? 3. And then it goes in exactly 8 times 3 is 24. So when you subtract it, 0. This number is your remainder, so this one doesn't have a remainder. So the quotient, or the answer, is 123. Okay, so that process of how many times or what do you multiply 8 by to get 9, or how many times does 8 go into 9, whatever that is, it goes on top, it gets multiplied by the 8, written underneath, you subtract. We do that same process, but now with polynomials. So yes, there's slight differences because you have polynomials, but the overall steps are the same. And that's why kind of relating it back to something you already know, hopefully that's helpful. So now we're going to go through the example A with polynomials. So we set it up this exact same way. So x squared plus 7x minus 30, that's our dividend. That goes in the division symbol. We're dividing by x minus 3, so that goes outside. So here is where there is a slight difference because we have polynomials, not just numbers. You are only paying attention to, and you want to make sure that this is always written. We're going to talk about it as standard form, but it's always written where your highest power of your variable, that term is written first. So we want it to be x minus 3, not the 3 in front of the x. So we're only paying attention to the x in this first step. And you have to ask yourself, what do you have to multiply x by to get x squared? So you look at the x and you look at the first term in your polynomial of x squared. And I heard somebody say it, you have to multiply x by x to get x squared. So I'm going to write x on top. Now where you write it doesn't matter. I try to keep my, like if it's just x, I'm going to write it above the x term. But if you wrote it above the x squared, it doesn't matter where you write it. And now this x gets distributed to the x minus 3. So we have the number up here, just like we then multiplied the 1 by 8, we multiplied the x by this whole quantity. So x times x is x squared, and I want to keep like terms lined up, so I write the x squared underneath the x squared. X times a minus 3 is minus 3x. And now this whole quantity gets subtracted. Here's where you have to make sure you're subtracting the whole quantity. So if I'm subtracting this whole quantity, this is where easy mistakes are made. So your first term should always cancel. X squared minus x squared, that cancels out. And then I have 7x minus negative 3x. That is 10x, yes. So make sure you're carrying that negative to the minus or the negative 3x as well. So that's 10x, and then I bring down the last term of minus 30, and I repeat the process, but now I'm going to say, what do I multiply x by to get 10x? I think I heard it 10, yes, and positive 10, so up top I write plus 10, so it's positive, and then I distribute the positive 10 to the x minus 3 and write that underneath. So 10 times x is 10x, 10 times a minus 3 is minus 30, and I subtract that whole quantity, so 10x minus 10x cancels out as it should. Negative 30 minus negative 30 is really negative 30 plus 30, and that's 0, so there's no remainder. So your answer, your quotient, is x plus 10. All right, any questions at this moment? Okay, so what I said I want to relate this to factoring. I'm going to do that really quickly because factoring is a form of division. So say the polynomial we started with, x squared plus 7x minus 30, say I told you to factor that. So it's a trinomial. How do you factor a trinomial? Yep, we do the diamond. And we're multiplying to what? Negative 30, adding to 7. What numbers work? 10 and negative 3. And then because there's a 1 in front, you could split the middle term and then factor by grouping. But because there's a 1 as your a value, you can go straight to your factors using these numbers. X plus 10, x minus 3. So here's what I want you to notice. When you divide x squared plus 7x minus 30 by x minus 3, you get x plus 10. Factoring is a form of division. So factoring will still be part of this chapter. Now, when I say use long division to find the quotient, you need to do the long division. I want to see that you know the process because not everything can be factored, but you can relate factoring to your long division. Factoring is a form of division. Because we were dividing by x minus 3. Yeah. So whatever you're dividing by would be one of your factors. The other one would be the quotient. But like I said, not everything can be factored, so we can't always do the factoring, which is why long division is a process we can use. Long division will always work. The process we're learning tomorrow is another process that sometimes works, but not always. So long division, why we have it, is because it always works. Factoring will work if you can set up a diamond. So if, we're multiplying to a number, adding to a number, but there aren't numbers that work, that means it can't be factored. All right, so what I'd actually like to do, I am going to have you do example B, but I'm going to have you wait because I want to go through one of them on the back, and then I'll just have you do 2 examples. I'll give you time to work on both at the end here. So in the first one, we did not have a remainder, but as you know with long division, not everything divides evenly. Sometimes you have a remainder. Sometimes you get decimals. So for the back, I just want to review. I'm going to do another long division problem with numbers, 44 divided by 3, and review when you have a remainder how you wrote your answers, so how we write the answers with polynomials as well. So if I divide 44 by 3, 44 goes in the division symbol, 3 is on the outside, and quickly do this process again. So 3 goes into 4 one time, 1 times 3 is 3. Subtract. 4 minus 3 is 1. Bring down the 4. And then 3 goes into 14. 4 times 3 is 12. And 14 minus 12 is 2. So then you knew you were done when this number could no longer go into this number. 3 can't go into 2. So there were a few different ways you learned how to work with this. Probably the first way, again, I have not taught elementary school, so I've really not taught long division. But one of the first ways, I think, when I remember learning it, is you learn how to write it this way, 14 and then R2, something like that, 14 remainder 2. Another way to write it, though, because you probably learned then at some point you expanded and said put a decimal point, add a 0, and keep going, and then you have a decimal. That was kind of building onto it. We don't want to do that. But another way to write this is to write it as your quotient of 14 plus your remainder of 2 over what you were dividing by, your divisor of 3. Which, for numbers, 14 plus 2/3 is just 14 and 2/3. But this form, so writing your quotient plus your remainder over your divisor, that is the form we're going to be writing answers with polynomials. So if you get a remainder, this is the form you will write it in. So it's important for you to see where the fraction, where the 2 is coming from, and where the denominator of 3 is coming from. So you know how to relate that with your polynomials. So if we go through example A, and this one, again, is written differently. I just want you to see that when you are multiplying by a quantity to the negative first, that means you are dividing. So this really means we are taking r squared plus 5r plus 7 and dividing it by 1 minus r. So if it helps to rewrite it as division first, that's fine. And then also, before you divide, in your divisor, like I said with the first problem, you want your variable to be written first or in front. So because it's minus r, that means r is negative. So this would be negative r plus 1. So if I rewrote that by switching the order of the terms, negative r plus 1 would be what I'm dividing by. So when I set this up, I have r squared plus 5r plus 7 in the division symbol and negative r plus 1 in front. And so here's a second example to make sure you understand the process before you try one. I look at the negative r. What do I multiply negative r by to get positive r squared? Negative r. So I would write negative r on the top, and then I distribute that to the negative r plus 1. So negative r times negative r is positive r squared. Negative r times positive 1 is minus r, or minus 1r. Subtract the quantity. So the r squareds will cancel. And then make sure you're doing 5r minus negative r. What'll that be? 6r, thank you. So just make sure you don't have 4r written there. It's really 5r plus r. And then I bring down the plus 7. And then negative r, I now look at the 6r. What do I multiply negative r by to get 6r? Negative 6, so I put a minus 6 on the top, or if you had plus negative 6, that's fine. I distribute negative 6 to the negative r plus 1. So negative 6 times negative r is positive 6r. Negative 6 times 1 is minus 6. I subtract the whole quantity. 6r minus 6r cancels out. 7 minus negative 6 is 13. So there's usually always a question of how do I know when I have a remainder? How do I know when I can't go any further? When you get something that no longer has a variable. So there's nothing I can multiply negative r by to just get 13 because there's no r in this. So I know this is my remainder. And so I'm going to take what I got as a quotient. So how I'm going to write the answer, I have negative r minus 6. And then to write it this way, I put plus. So make sure you're putting an addition symbol in between. Or if your remainder was negative, you could put a minus there. And then it's your remainder, which is 13 in this case, over your divisor, what you were dividing by. So that was 1 minus r. Or if you put the negative r plus 1 on the bottom, that's fine too. So this would be the answer. When you get a remainder, this one, if we tried to factor, we would not be able to factor this. There's nothing that multiplies to 7 and adds to 5. So when you get a remainder, that's a case where factoring would not have worked to divide. But polynomial long division does work. So what I would like you to do is first do example B on this side of your note sheet, but also work on example B from the other side. So work on those two examples. We still have 9 minutes. Work on those two. I'll be walking around in a minute here to answer questions, and then I'll make sure that you can check your answers as well to make sure you have this down. And then there is practice as well on the bottom of your sheet to get additional practice with this. So you could start working on that with time left or outside of class to make sure you fully understand polynomial long division. Or you want, so what do you multiply x by to get x? Positive 1. Then it would be positive x. Get positive x. So then we can subtract x by x. Oh, there you go. So you're not trying to cancel these out like this. These are going to cancel out on these subtractions. So you always have to see what I negative A. When multiply to the negative 3A, always find that positive. Yeah. 3 times negative 3A. And then positive 3 times 2 is positive 6. So now when you subtract these, negative 3A minus negative 3A is plus 3 cancel out. And then you do have negative 3 minus 6, which is oh, and then make sure you wrote this thing up here. So, oh.